I'm walking in the mountains of the moon. I'm on the trail of the Renaissance artist Piero della Francesca, and so I've come to the town in northern Italy which Piero made his own.
There it is, Urbino. I've come here to see some of Piero's finest works, masterpieces of art, but also masterpieces of mathematics.
The artists and architects of the early Renaissance brought back the use of perspective, a technique that had been lost for 1,000 years. But using it properly turned out to be a lot more difficult than they imagined. Piero was the first major painter to fully understand perspective, and that's because he was a mathematician as well as an artist. I came here to see his masterpiece, The Flagellation of Christ, but there was a problem.
I've just been to see the flagellation, and it's an absolutely stunning picture. But unfortunately, for various kind of Italian reasons, we're not allowed to go and film in there. But this is a maths programme, after all, and not an arts programme. So I've used a bit of mathematics to bring this picture alive.
We can't go to the picture, but we can make the picture come to us. The problem of perspective is how to represent the three-dimensional world on a two-dimensional canvas. To give a sense of depth, a sense of the third dimension, Piero used mathematics. How big is he going to paint Christ? If this group of men here are a certain distance away from these men in the foreground. Get it wrong, and the illusion of perspective is shattered. It's far from obvious how a three-dimensional world can be accurately represented on a two-dimensional surface. Look at how the parallel lines in a three-dimensional world are no longer parallel in the two-dimensional canvas, but meet at a vanishing point. And this is what the tiles in the picture really look like.
What is emerging here is a new mathematical language which allows us to map one thing into another. The power of perspective unleashed a new way to see the world. A perspective that would cause a mathematical revolution.
Piero's work was the beginning of a new way to understand geometry. But it would take another 200 years before other mathematicians would continue where he left off. Our journey has come north. By the 17th century, Europe had taken over from the Middle East as the world's powerhouse of mathematical ideas. Great strides have been made in the geometry of objects fixed in time and space. In France, Germany, Holland and Britain, the race was now on to understand the mathematics of objects in motion. And the pursuit of this new mathematics started here, in this village in the centre of France. Only the French would name a village after a mathematician. Imagine it in England, a town called Newton, or Bull, or Cayley. I don't think so. But in France, they really value their mathematicians. This is the village of Descartes in the Loire Valley. It was renamed after the famous philosopher and mathematician 200 years ago. Descartes himself was born here in 1596, a sickly child who lost his mother when very young. So he was allowed to stay in bed every morning until 11 a.m, a practice he tried to continue all his life. To do mathematics, sometimes you just need to remove all distractions and to float off into a world of shapes and patterns. Descartes thought that the bed was the best place to achieve this meditative state. And I think I know what he means. The house where Descartes undertook his bedtime meditations is now a museum dedicated to all things Cartesian.
Come with me.
Its exhibition pieces, arranged by curator Sylvia Garnier, show how his philosophical, scientific and mathematical ideas all fit together. It also features less familiar aspects of Descartes' life and career.
So he decided to be a soldier in the army, in the Protestant army, and two in the Catholic army. No problem for him, because no patriotism.
Sylvia is putting it very nicely, but Descartes was in fact a mercenary. He fought for the German Protestants, the French Catholics, and anyone else who would pay him. Very early one autumn morning in 1628, he was in the Bavarian army, camped out on a cold riverbank.
Inspiration very often strikes in very strange places. A story is told how Descartes couldn't sleep one night, maybe because he was getting up so late, or perhaps he was celebrating St. Martin's Eve and had just drunk too much. Anyway, problems were tumbling around in his mind. He was thinking about his favourite subject, philosophy, but he was finding it very frustrating. How can you actually know anything at all?
Then he slips into a dream. And in the dream, he understood that the key was to build philosophy on the indisputable facts of mathematics. Numbers, he realised, could brush away the cobwebs of uncertainty. He wanted to publish all his radical ideas, but he was worried how they'd be received in Catholic France. So he packed his bags and left. Descartes found a home here in Holland. He'd been one of the champions of the new scientific revolution, which rejected the dominant view that the sun went round the Earth, an opinion that had got scientists like Galileo into deep trouble with the Vatican. Descartes reckoned that here amongst the Protestant Dutch, he would be safe, especially at the old university town of Leiden, where they valued maths and science. I've come to Leiden too. Unfortunately, I'm late.
Hello. Yeah, I'm sorry I'm so late. I got a puncture, so it took me a bit of time. Yeah.
Henk Bos is one of Europe's most eminent Cartesian scholars. He's not surprised the French scholar ended up in Leiden.
He came to talk with people, and some people were open to his ideas. This was not only mathematics, it was also mechanics, especially. He merged algebra and geometry.
Right.
So you could have formulas and figures and go back and forth.
So a sort of dictionary between the two provides...
Yeah.
This dictionary, which was finally published here in Holland in 1637, included mainly controversial philosophical ideas. But the most radical thoughts were in the appendix, a proposal to link algebra and geometry. Each point in 2 dimensions can be described by 2 numbers, one giving the horizontal location, the second number giving the point's vertical location. As the point moves around a circle, these coordinates change. But we can write down an equation that identifies the changing value of these numbers at any point in the figure. Suddenly, geometry has turned into algebra. Using this transformation from geometry into numbers, you could tell, for example, if the curve on this bridge was part of a circle or not. You didn't need to use your eyes. Instead, the equations of the curve would reveal its secrets. But it wouldn't stop there. Descartes had unlocked the possibility of navigating geometries of higher dimensions, worlds our eyes will never see, but are central to modern technology and physics. There's no doubt that Descartes was one of the giants of mathematics. Unfortunately, though, he wasn't the nicest of men.
I think he was not an easy person. So, and he was very much concerned about his image. He was entirely self-convinced that he was right, also when he was wrong. And his first reaction would be that the other one was stupid and hadn't understood it.
Descartes may not have been the most congenial person, but there's no doubt that his insight into the connection between algebra and geometry transformed mathematics forever. For his mathematical revolution to work, though, he needed one other vital ingredient. To find that, I had to say goodbye to Henk and Leiden and go to church.